Hello everyone, welcome to this video. So today we're going to discuss the Azure Key Vault Provider for Kubernetes. It's basically a provider that allows you to pass Azure Key Vault secrets into Kubernetes pods. So there are many other solutions that you can use that more or less do the same thing. For example, the HashiCorp Vault is one example. But if you're using Azure, I find that using Azure Key Vault Provider is basically very convenient since you have everything inside your Azure cloud and just easier to manage. There are also other ways that you can more or less do the same thing, but they are very convoluted. In order to take a look at them, let's first discuss what the basic premise is and what the basic problem is and what is the problem we're trying to solve. So typically you'd have, in your repository, you'd have a deployment YAML here. This is basically a deployment YAML for a website. The website depends on a backend database in order to function. And the backend database, of course, needs a host name, username, password, and so on. And so we have a very clear problem here is that these are in clear text. We don't want to pass these parameters or to pass these environment variables into the pod in clear text for an obvious reason. Even if you could some way, construct this YAML file using Helm or using your pipelines, if you can construct this in a secure manner and then pass it into the pod, you probably wouldn't want to do this in the first place. And the reason is you can, let's deploy actually this pod so that you can see apply-f and then the deployment YAML that we have. And so let's get the pod, and this is the pod. Let's describe the pod to see the contents of it. And you can see here very clearly, DB host, username, password, and everything is in clear text. So apparently this is of course not what we want to do. So what we can do is use secrets, and this is, for example, a secret file, and the secret YAML basically creates secret data. It's coming from string, but once this is saved inside Kubernetes, it's going to be saved in base64 string. So let's deploy the secret as well. So again, let's just clear this and do kubectl apply secret.yaml. And now we're deploying our secret. So now kubectl get secret, and this is our secret. So we can do kubectl describe secret. Very good. And you can see here we have 12 bytes of host, password, and username. We don't exactly see the real values. I mean, there are ways to get the real values behind it, but that's not our concern. Like, it's somewhat more obscure right now. And you can secure this using different types of permissions and so on. So then, okay, if you can do this, what's the problem? Well, the problem is if you move this pod to a new cluster, you're going to have to move the secret with it, or basically redeploy the secret with it. So you're going to have to deploy the secret using your pipeline, and again, the pipeline is facing the same problem. It has it now in a different file. So here, to make this let me do this very quickly. Now we need this to come from the secret. So instead of value here, we said value from. The value is gonna come from a secret keyref, and the key is here is the host. And then you also need like the name of the secret itself, and it's this nginx secret. So let me copy that and do it like this. So basically here we're telling, get the host from this secret, and the key to look for is host, which is this one. So it's gonna get this value, right? So things are good. Now we can, duplicate the same thing. Now everything should be fine. I can actually redeploy my pod. So kubectl apply-f deploy deployment.yaml. This is the pod. So I get the new one and describe the pod. And now if we look in the secrets, it is set to the key host in secret nginx secret. And again, it's a little bit more secure. And the only problem is I still need to do this. So there are ways that you can, like instead of putting the real secret here, we can do something like this. So let's show you. So instead of this, we're gonna do, underscore db posts. And I'm using double underscores here as placeholders. And this is basically going to be a placeholder. So now I just want to commit. And now in my pipeline, so I'm just creating a brand new pipeline starting with an empty job. So it basically does nothing. And all I need to do is to come here and do a replace token. I can add this job. And this is a free job off the market. So the target files is, YAML files. You can even choose the root directory. So anything in deploy right here. So you can target the file specifically. And here is my token prefix and suffix is basically double underscore we talked about. So it's going to look for a variable named like db host, for example, or db username, and so on. We add a publish build artifact job, and now we need to add variables to our pipeline. So these can come from variable groups as well. Like if you go to environments and you can have variable groups, I'm just gonna go like the easy way and just add pipeline variables right here. So I can add, db hosts is secret hosts, and you can actually lock this so it's like a password. And we just also need to copy those YAML files. So let's search for a copy job. And this is copy files. And so our destination is the build artifact staging directory. So this is the target folder, and the source folder is going to be, whatever is in this deploy. So let's queue this, and I want to show you what it does. And so we have one artifact produced. We can now click on this artifact and see our drop folder. It contains the secret, but now if we take a look at the secret, I've downloaded it. We can see the proper values has been replaced and inserted. So this is the original one with the tokens, and then the pipeline has replaced the tokens for me. So again, this is one solution that you can do, but as you can see, it involves a lot of putting placeholders in the right places, then making sure the variables are all with the proper name, and it's like a big mess, to be honest. Sometimes it could be a good solution, but what if you want to secure this even further? Use KeyVault. Now this is also going to be for other stuff, like also if you're ever publishing your website using HTTPS or something, you probably want to assign a TLS certificate to your ingress. And again, where is the certificate going to come from? Now it's going to be very difficult to pass the certificate using your pipeline, but if you're using Azure Key Vault, then you can just save the certificate there, and it's going to take care of itself. So we're going to discuss that part now. We go to the deployment. Now I'll share the link for this in the description, and you can see there is a walkthrough here that is very easy to use. So I've already have my AZ login and everything like that. So if you're doing that, make sure you follow the steps exactly. So the Key Vault resource group that we want to create, I'm just gonna go to the resource group where I have this AKS. My Key Vault location is West Europe. Choose the location that is closer to you. I'll use my own name. So the next step is to add the Helm repos. And so this is basically the Helm repository where the CSI driver is installed. And then I'll just deploy the package to my Kubernetes. Now, before running this, make sure that your kubectl config is pointed to the cluster where you wanted this to be deployed. So I'll just run these right here. and then run these two. So now we are deploying the CSI Secrets Store Provider for Azure Key Vault onto our cluster. And now we have to install the Key Vault. So I'm not gonna install the group because the group already exists, but I'm gonna immediately go and install the Key Vault. Good, so now my Key Vault is installed, and I can actually verify by going to my Azure Resource Group, and here is my Key Vault that I wanna use. So we can actually go ahead and start creating the secrets. I mean, in the walkthrough, there is a very good way to create the secret here, but I'll just do it using the UI instead. And I'll go to secrets, generate a secret. So this is going to be my DB host. Good, and now we have all our secrets saved into this Key Vault. So the next part is, okay, so how is the Kubernetes going to gain access to this Key Vault? So we need to do access policies, and we need to add an access policy to allow our Key Vault, our Kubernetes to access this Key Vault. But it's going to need to do, to have some kind of service account to do that. So the easiest way is to just use a service principal, and what service principal is like a service account. So this is basically the process of creating a service principal. Is we run this AZADSP, which stands for Azure Active Directory Service Principal. Create for RBAC means create for role-based access control. So I want to create a service account that can be assigned permissions onto Azure. And skip assignment means don't assign it to anything. I will assign it manually. And then you use the name of the account that you create, and you want to query the password because you want to save the password in this variable right here. And then you do the client ID. So and there is a small typo here. You should add a $sign before this part. So and now we got the ID in this value as well. And now, just to show you what we created, you can come to your Azure Active Directory tenant, and you can go to app registrations. And here is in app registrations, and you can find the service account that you just created. And you can see here is the client ID, tenant ID, and all the details. And the secret we created is just saved here. So you will find here RBAC, and there is a hidden secret here. So this is basically what we've done. We could have done it using the UI, but using command line is much more convenient. And now we need to set the policy. So you can do it from here. I'll also do it from the interface just to show you exactly what it entails. So we add an access policy, and I don't want to use a template. So the access policy can only get secrets. That's the only thing it needs to do. If you're using, an ingress for certificates and so on, you're going to have to add get keys and also get and list certificates, I think. But I think you don't need to do that right now unless you actually need to go and grab certificates from the Key Vault. For now, secret permissions is get, and that's all we need. Now we select the principal. Who are we assigning this policy to? And the policy is assigned to our account that we just created. Right, and then we add. So now we have added permissions for this service account or service principal to do get on the secrets, and we save. Don't forget to save. And now we need to store the secret, the credentials of the service account, which is the client secret and client ID that we got. We need to store them as a secret in Kubernetes. Good, and the secret is created. So actually, if I come back here, I can do kubectl get secrets. So now this secret is going to be used by the CSI driver in order to contact the Key Vault. So the next step we need is to actually deploy what is called a secret provider class. And a secret provider class is basically a definition for the key vault that we're going to use and how to reach it and what to grab from it and so on. Because maybe my key vault contains other secrets that I don't need to bring, and we're also going to specify how to reach them. So let me just copy that to here. And let's edit this very quickly. So the first thing we're going to edit is the key vault name right here. I know my key vault name. So like so. Is it using the pod identity? So we use the service principal to contact the key vault, or we're using a service principal, but we could have used any other methodology as well. So we could have used the identity of the pod. So the pod itself is going to be responsible for providing those permissions. Or we could have used VM managed identity. If this was running in a VM and the VM had a managed identity, we could have used the managed identity. We could also have created a user assigned identity, which in my opinion is a cleaner way. So consider using a user assigned identity later on. You can find more details about it in documentation. I think a service principal is just easier a little bit to handle, so I don't need to create anything else. And here I put the name of the key vault that I want to access. So this is the name of the object we're creating. Don't confuse those two. This is just the name of the class. So you can add like class to it, but I'm not gonna. It's just easier for me to see things like that. Key vault. This is the actual name of the key vault. And then what do we need to grab from it? So well, we need to grab a secret object from it. We can also grab other stuff like certificate, not just secret, but here we're grabbing a secret and we know the name of the secrets we want to grab. It's db host, and this is a list, so you can actually add to it like this, and db user and db password. So these are the three things we want to extract from the key vault. And just to understand what we're doing, we are grabbing these three. So just set the object name that we want to bring, right? And then the tenant ID. And the reason the tenant ID is needed is that it's going to need to authenticate to this key vault using the client ID and client secret. So we created a client ID and client secret, but we didn't tell it which tenant it is. So I have my tenant ID right here. I'm just going to copy it and paste it. So this is the tenant ID onto which the app registration was done. And I'm gonna run this. Good, so now I can do kubectl get secret provider class. And I have my secret provider class right here. So you're gonna wanna do an individual secret provider class for every key vault you have. So if your applications need multiple key vaults, or you need to grab secrets from multiple key vaults, then you need to do multiple secret provider classes for it. And now we just deploy our secret. So the way we deploy it here is using a volume mount. We're going to talk about that very quickly. I'll just copy this part right here, and I will go to my deployment YAML, and in the end right here I'll paste this. So the volume mount here, I can call it, secrets mount, and have to use the same name here. So first let's see the volume definition. It's a secrets mount, and the driver I'm going to use is the secret store.csi.kubernetes.io. This is just the namespace of the driver. And is it read only? Yes, I don't need to change my secrets. And what secret provider class am I going to use? So you use the secret provider class with the same name as the key vault that we want to access. And what are the credentials I'm going to use in order to connect to this key vault? So it's the secret name here, secret store creds, and that is the same name as the secret we've created. It contains the client ID and client secret in it of the service principal. So now that's all done, we can actually save this and deploy this part. So we want to get the pod, and you can see here this pod. So first let's describe it. to show you something. And we can see here the volume that we're mounting is the secret volume right here. And it's actually mounted on this location, Secrets Store. So if I hop into the container, and I can do that by kubectl exec-it and then the name of the container, sorry, of the pod, and then bash. So now I'm inside the container. If I do an ls, I'll see a mount folder right here. And if I do /mount, we see a secret store. And inside, I will find the values for DB host, DB password, and DB user. So I can, you know, here is the, you know, secret host. Super secret password, and so on. So this is fine. However, my application is not configured to grab the secrets from this location. It is actually configured to grab those secrets from the environment variables. So how do we mount these values as environment variables? And there actually is a very easy way to do it. So I'll take this whole part. This is the secret provider class, and I'll just create a new file right here. I will call it secret provider class.yaml, and I paste the secret provider class. Now the objective here is that we want to create secrets in Kubernetes. So we already have our deployment looking at environment variables that come from the Nginx secret. So we want to change that. We want it to come from a different secret, and we want that secret to be created by our provider. So we come back to our provider class, and we're going to add secret objects. And the secret objects basically tell it what the secret name do I want to create. So secret name is going to be Nginx secret, which is the same name I'm actually using in my deployment right here. And the type of the secret is opaque. So this can be any type you want. You're basically creating a secret that is coming from KeyVault, but the secret parameters you're defining right here, it is like you're defining this file. So if you're creating a TLS, you know, so your type is TLS, and then you supply the TLS details as follows. So here we're creating an opaque secret, and we have 3 keys and 3 values that we want to pass. So let's do that as well in the provider class. There is a data part, and the data is coming from where? The data is coming actually from the object below. So we just, you know, take the same name as here. So the object name is DB host, and the key we want to create is the same name as the key we're expecting in the deployment file. So the key is host. So let's repeat this. And this one is username. And this one is password, I think. And here the names are DB user and DB password. So now let's just revise what we have done. We want to create secret objects as a part of, you know, we want this provider to create secrets for us. The secret we're going to create is Nginx secret, and it contains, it's type opaque, and it contains 3 keys, which are host, username, and password, same as these one, host, username, and password. And the values for them are going to come from this object in KeyVault. And this object on KeyVault is actually defined below, right here. Right? So that's basically what we're creating. So before we proceed, let me delete the existing secret. Kubectl get secret, just to show you. And this is the Nginx secret. that we depend on in our file. So we want to delete that because we're going to recreate it using our provider. So now the secret is deleted. I'll also delete the deployment. So now let's just update the provider class that we've created. So we have our provider class right here, and we have it in a file right here. So we want to just update that. So kubectl apply secret provider class. So let's get the secret provider class and let's describe it so that we see the details. Good, so we can see here the parameters. We are grabbing from KeyVault 3 secrets: DB host, DB user, and DB password, and we are using those to create a secret with the name host, with the name with the type opaque, and the secret name is nginx secret, and these are the key and value for objects inside this secret. So that looks very good, very promising, and now we need to deploy our application again. So just for you to know, if I get all the secrets now, we're not going to find the nginx secret right now. And the reason is it is only loaded when it's needed. So it's not there unless actually the application is deployed. So now I do kubectl apply the deployment. And now if I get the secret again, I should find my nginx secret loaded. Right? So the secret is automatically loaded by the Secrets Store provider. And let's describe it to see the contents. And again, host, password, and username. And again, that means that our application could use it. So if I do a get pod, and now this is my pod, let's actually describe it. So kubectl describe pod. We can see, of course, the volume is still mounted. But here are the environment variables. They're coming from nginx secret as promised. So let's also hop into the container again. And let's actually echo the value of db underscore host. And you can see the environment variable is loaded properly. But now this is coming from KeyVault instead of everything being, written statically or whatever. So one just peculiar thing to tell you about this is that, well, theoretically speaking now, you do not need this volume mount because now you're passing secrets. So let's remove this volume mount right here. And I want to show you something peculiar. So we've removed the volume and the volume mount because we just want to depend on our secret, right? So now delete the deployment and deploy it again. So again, deleting the deployment should remove the secret as well, because the provider is going to see that this secret is no longer needed. So if I get secret, it's still there, but it should be removed at some point. And now it is removed. So let's deploy again the deployment, but after we have removed the mount from it, the volume mount. And the deployment is created. So now let's get the pod and create container config error. So why is that? Let's describe. So the secret is not found, and it's never going to be found. In reality, you need this volume mount to happen. And the reason is, this is the only way the provider knows to actually load the secret, even though you might not need the volume itself. So now we can bring this back and deploy our container again. And now our container is running because it could find the secret eventually. So there you go. So how does that affect our workflow? Well, now you can actually save all that into now you don't need this secret file anymore. You can just delete it. So because the secret is going to be created automatically as a part of provider working for us. So now I can move this file. Now this has no secrets whatsoever. It's nothing special in it. The only part is the environment preparation. And now, so for every new cluster I create, I have to include the process of adding the provider to it. But if that is already done, then I can actually take this deployment and this secret provider class and deploy them together to any new cluster that is just configured to begin with to deal with KeyVault, and it will automatically do that. It just greatly simplifies moving the pods from one location to another. And the added benefit of it, well, all my secrets and certificates and everything are saved here securely in KeyVault. So it's not, exposed in pipelines or, like there is only one place where the secret exists. It's in KeyVault. And I don't need to worry about, copying the secret to multiple locations. The secret doesn't need to exist in my pipeline anymore, so I can actually come here into the pipeline and simplify my pipeline greatly. Now I want to deploy those YAML files, but I actually don't need to do anything in it. I don't need to modify the YAML files, just deploy all the YAML files to the artifact drop, and I can remove my variables from here. So no need to save variables anywhere, and everything just works fine. Now there is a lot more to this provider. It can do, like there is stuff related to certificates that are really fancy that you can do and so on. I'll let you explore that. That's just a very quick intro on how to use it. And as you saw, there are many steps to do, but they're all like steps that make sense, really simple steps, nothing too convoluted. I hope that helps, and I hope you learned something.